My setup and tips on the Qidi Maule M7 510 millimeter sub 250 gram brushless beginner plane. It's not the best beginner plane out there, so I would not recommend this as your very first plane. It does require some rudder input to get nice coordinated turns with it, but it's a good flying plane, so I would recommend it as your second or third plane, but not as your very first one. I think you're going to have a better experience with a different plane. I will have my favorite sub 250 gram planes listed in the show notes, and I can tell you that there's a link to the Volantex Ranger 600. It is a brush motor pusher, but it is, with the stock LiPo, it is sub 70 gram. You can make nice coordinated turns with it just using aileron and elevator, using a little bit of rudder. You can make very tight turns with it, even in fully stabilized mode. That is the one I most highly recommend as your very first plane. There's a link to it in the show notes, as well as other great flying, my picks of the litter, sub 250 gram planes in the show notes. Okay, so one thing I like about this plane is that they included 2 ports on the board for external receivers. So because you can't bind, at least when I got this plane, you could not bind up to the protocol using multi-module for a multi-protocol transmitter using OpenTX or EdgeTX. It wasn't supported at the time that I got this plane. So, there's a 3-volt port and a 5-volt port. And so I took a Radiolink R8FM SBUS PPM receiver and I plugged it into the 5-volt port. Even though it's just a 1S LiPo that fully charges only 4.2 volts, that receiver worked fine. I never had a problem, with radio communications with this plane, with the Radiolink R8FM SBUS PPM receiver in this plane, with my TX16S transmitter. It worked flawlessly. Okay, so the first thing I want to tell you is, I've got my setup sheet here for my stock setup. All right, so on the stock 1S, the 1S 500 milliamp hour LiPo is the stock LiPo it comes with. Doing mixed mode flying with it, and I'm never easy on the throttle when I'm flying, even with these little beginner planes. I get 8 minutes of mixed mode flying, leaving 3.6 volts per cell. That is pretty darn efficient for a 1S LiPo on this plane with a brushed motor power system. The plane is neutrally balanced at the CG that I specify down below. There's no linkage adjustment on the aileron control horn, okay? But on the servo arm, I had it's a 3-hole control arm, and mine came in the center hole. On the elevator control horn, it was in the outermost hole, 3-hole control horn. On the elevator servo arm, outermost hole, 2-hole control arm. On the rudder control horn, it was the innermost hole, 3-hole control horn. That gives you the most movement on the rudder with that innermost hole on the control horn, and the rudder servo arm was the outermost hole, which gives you the most movement on the rudder. I may have actually changed that from stock. They don't typically set up the rudder for the maximum amount of movement, so I may have done that. But that's the way I have mine set up as far as the linkage. And I like it set up that way for the stock transmitter. All right, my controlled surface deflection is measured opposite the control horns in manual mode. So before you initiate the gyro on this plane. All right, so because the transmitter is not programmable, the dual rates and expo or whatever is internally, configured in the firmware in the transmitter. But the deflection on the ailerons was 30 millimeters up and down with my setup for the stock transmitter. The elevator is 26 millimeters up and down, and the rudder is 45 millimeters left and right. That's the way I have mine set up. So for for enough control authority on the rudder, the aileron, and the elevator using the stock TX and having the controls pretty smooth, that is the setup that I recommend. For the CG, the specified CG is 92 millimeters plus or minus 5 millimeters from the leading edge of the wing as marked. Okay. Well, I found it tail heavy at the stock location. So I have my CG location set at 88 millimeters from the leading edge, from the front area of the CG marks. Basically it's at the very front part of where the CG is marked on the bottom of the wing. Now it says 92 plus or minus 5. Okay, so I'm within that range that they specified, but I think that you need a little more. I think you need the CG further forward so that it's not tail heavy. I use a launch throttle at 70% because the plane does not have a lot of power on a 1S brushless power system. So 70% throttle with a moderate chuck with a slightly upward angle. When you release it, the plane takes off absolutely fine. There's no worries there. All right, so now let's take a look at the setup for the TX16S. All right, so same information, except that I do have information on here that I attached the R8 FM, Radiolink R8 FM SBUS PPM receiver to the 5-volt port. I've read where some people had problems binding to it with an external receiver. They've stated they had to bind to the receiver outside of the plane, maybe in another plane, and then transfer the receiver to the plane. I didn't have that issue. Okay, I connected the receiver to the 5-volt port. I powered up the plane. I put the receiver into bind mode. I put my transmitter into bind mode, and with the multi-protocol transmitter and multi-module, the protocol for the Radiolink receivers, and including the R8 FM, is protocol Radiolink subprotocol Air. And I was able to bind up to it just fine. I didn't have to do anything special other than put the receiver into bind mode once I powered up the plane. It bound right up. So I didn't have any of those types of issues that I have read about. All right, so the control linkage for the aileron servo arm is outermost hole and 3-hole control arm. Elevator control horn is outermost hole, 3-hole control horn. Elevator servo arm is the outermost hole, 2-hole control arm. The rudder control horn is the innermost hole, 3-hole control arm. And the rudder servo arm is the outermost hole, 2-hole control arm. So I've got my linkage set up on the aileron and the rudder for the maximum amount of movement. I typically have to soften up the elevator linkage on these microplanes because it's usually too twitchy for me. So with the TX16S, this is the way I have my linkage set up, and that is nice and smooth with the amount of dual rate and expo I have dialed in. Okay, so once again, the deflection of the control surfaces is measured opposite the control horns with the gyro in manual mode, before you initiate the gyro. So the aileron, the elevator, and the rudder, I have 100% dual rate on all three. On the aileron, they have 60% expo, the elevator 60%, and the rudder 30%. Now the amount of deflection is the same on the elevator and the rudder because I have them set up the same way for the stock TX. But you'll notice I got 5 millimeter more movement on the aileron with this linkage setup than I had with the stock TX because I tested this with the stock TX and it just made the ailerons way too twitchy for me. Okay. But being able to dial in enough expo on the TX16S really smoothed it out. And that increases your roll rate. It has a decent roll rate with a TX16S with 35 millimeters of deflection. It's not a problem. Okay, much better than at 30 millimeters with stock linkage set up. All right, so it's a really good plane. Like I said, it's not the best one, but it makes a good second or third plane. So there's the information. Links to everything will be in the show notes, including a link to the Radiolink R8 FM receiver that I used. There will be links in there to these PDF files. So if you want to download and keep these setup files for your own reference for the stock TX as well as the TX16S or any programmable transmitter. You'll use the same setup that I use in the TX16S. Any programmable transmitter where you can set up your dual rate in your Expo, this setup is going to work fine for you. So links to these PDF documents are in the show notes. You can download them, use them for your own reference. That's a wrap on this episode. Okay, so thanks for watching, and I'll see you next time in the Tinkerz Lab.